Okay, so the first thing we're going to talk about is finding a point estimate for a population parameter. So a random sample is selected and the sample portion is calculated as follows. Guys, this really is nothing you are not like familiar with. Don't you remember like the probability, I want to draw here, the probability of finding something is what you want over the total. The same thing with the proportion. So the number of samples, X is the number in the sample that possesses the attribute. Now this is kind of a new word, but you should be kind of familiar with it. Attribute just means characteristic that members of a population either have or don't. So like whatever they're looking for, that's the attribute. N is the sample size, so to find the proportion is the number that possesses the attribute over the sample size. So what you want, how many have what you want over the total. That's the proportion that possesses the attribute in the sample. So what we're going to do first is we're just going to do a quick little example of finding the proportion. This should not be difficult. So it says estimate the fraction of defective transistors. I don't really know what that is, but it sounds pretty official. In a lot containing 100,000 transistors. Suppose a sample of size 800 is drawn from the lot and 5 transistors were found to be defective. So we need our X value and our N value. Remember, N is our sample size, so what sample did they draw here? 800. And X is how many possess that attribute. Now this attribute is talking about defective transistors. So how many did they find to be defective? 5. So that's going to be our X value. So to find our P hat value, or our proportion, we're just going to take X divided by N, so that's going to be 5 divided by 800. Okay, and that proportion is going to be 0.00625. Okay, 0.00625. Now, just so we are on the same page, this guy right here, that 0.00625 is the estimate of the proportion of defective transistors in a lot of 100,000. That is the estimate of the proportion of defective transistors in a lot of 100,000. Okay? Now, just like everything else that we have been doing this chapter, we want to know how good is this estimate. Like, is this a good estimate or is it bogus? Remember, it all depends on the sample that you choose. So, to figure out how good this estimate is, we're going to figure out the confidence interval for the population proportion. Okay? So the confidence interval for the population proportion, this is just like what we've been doing with the means, but this is proportion. So if the sample size is sufficiently large, now with sample means, to figure out if the sample size was sufficiently large, we had to look at if the sample size was greater than 30, right? If it was greater than 30. This is not the same. Okay, when dealing with proportions, to determine if the sample size is sufficiently large, we have to take our N value times our P value. It has to be greater than or equal to 10. And, not or, and N times the quantity of 1 minus P, which don't forget, sometimes we call 1 minus PQ. So N times Q is greater than or equal to 10. Okay? The sample size has to meet both of these criteria to be considered sufficiently large. Okay? Then the confidence interval for the population proportion is given by this expression. Okay, look kind of familiar? We're going to have P hat instead of X bar because it's proportion, plus or minus Z sub alpha over 2 times the standard deviation of the sample proportions. Okay? Now, the standard deviation, or sigma sub P hat, is a little bit different. Here's the formula for sigma sub P hat. Okay? I am going to give these to you on the practice, and these are also on your purple sheets, your card sheets or whatever. Those are given. You just have to know when to look for them. So what we're going to do on number 2 here is we're going to just practice determining if the sample size is sufficiently large enough to do these. We're not going to do the whole thing. We are just going to start with determining if the sample size is sufficiently large enough. Okay? So it says determine if the conditions of the sample size being sufficiently large, are met for the following. So on part A, they're giving me a sample size of 45 and a p-value of 0.18. So here's what I'm going to do so I can use these. I'm going to go N is 45. I'm going to go P is 0.18. And then I'm going to go 1 minus P equals 1 minus that 0.18. Okay, so what I've done here is I've literally just listed them in their own cell so I can use them. Okay? Now the first thing I want to figure out is N times P. Okay? We want N times P to be greater than or equal to 10. So we're going to come over here and we're going to go equals, and then I'm just going to click on my cell for N times my cell for P. And the next one that I want to try is N times the quantity of 1 minus P. And so again, I'm just going to click on equals N times 1 minus P. Now, if I was given these parameters and they said determine a confidence interval for the population proportion, would I be able to? And the answer is no. This is not greater than or equal to 10, so the conditions are not met. Okay? I would not be able to do a confidence interval for this population proportion because the conditions are not met. Okay? Let's try it again for part B. For a randomly selected group of 90 adults, 34 adults have been administered the shingles vaccine. Okay? So the first thing we're going to need is our sample size. What is the sample size of this problem? 90 adults, very good. Then I want to find my p-value. Now, they did not give it to me outright. Sometimes I have to figure out that proportion on my own. So, again, the p-value is what we want over the total. All right, so the number that possess the attribute over the sample size. How many possess the attribute here? 34 over, what's my sample size? 90, very good. So that means my p-value is 0.37 repeating. And then my 1 minus p-value, again, is just equals 1 minus that guy. So, to figure out what they are, use the cell references. Don't round it, because if you round it, you're not going to get the right values. So first we want to figure out N times P. So we're going to take equals N times P. Is that greater than or equal to 10? That's awesome. Then we're going to take equals N times 1 minus P. Is that greater than or equal to 10? Perfect. Both of these right here, both of these are greater than or equal to 10. So are these conditions met? Yes, absolutely. We would be able to proceed with a confidence interval for the population proportion for that problem. Okay? Now, since we have done this concept all chapter, I'm not going to dive into each individual part. We're just going to take a step in and start trying these problems. Okay, so if we go down to number 3, it says, a survey of 345 randomly selected students at one university found that 301 students think there is not enough parking on campus. Find the 90% confidence interval for the population of all students at this university who think there's not enough parking on campus. Write an interpretive sentence of your finding. So the first thing we're going to need to do is we're going to find all this information. Again, I came up with all of this information on my own. This is not going to be given to you on the test. This again. So from this problem, what is my x value? How many possess the attribute that I'm wanting? 301. It says 301 students think there's not enough parking on campus. What was the sample size that they used? 345. Good. Now, to find your p-hat, you're literally just going to take x over n. So equals x divided by n. Don't round it, nothing like that. Like, it's just right there. Now, the confidence level is what they told me. What did they tell me my confidence interval is going to be here? 90%, so that's going to be 0.90. How did I use that to find my alpha? 1 minus that, very good. Then alpha over 2 just equals that divided by 2. Now, how do we find my critical value? What do I type in? Norm.s.inv of? Very good, 1 minus alpha over 2. That gives me a z-score of 1.64. That's what that means. This information, this confidence interval of 90% has boundaries of 1.64 and negative 1.64. That's what it means. Now let's take a second and let's find sigma sub p hat. To find sigma sub p hat, that's this guy right here. So what you're doing is you're taking the square root of, and you're going to have p hat times 1 minus p hat divided by n. Now notice 1 minus p hat is in parentheses, so we should put that in parentheses, but everything else should follow the order of operations. We can put this all in at once. So I'm going to type in equals square root of, p hat times, and then in parentheses we need to put 1 minus p hat. Close your parentheses. I'll scroll down here so you can see it a little better. Divided by n. Close your parentheses. Now, if that bothers the crap out of you, like if you're like, I don't like parentheses inside parentheses, that's too messy, you can always add another box here to find the value of 1 minus p hat, and then you could use the cell reference instead. That's okay. So that's my sigma sub p hat. Now let's find the margin of error. Remember, the margin of error is just this guy right here, the z sub alpha over 2 times sigma sub p hat. So we're going to type in equals, z sub alpha over 2 is just my z-score, so that's going to be this dude right here, times sigma sub p hat, which we just found, this guy right here. So my margin of error is 0.0295, 0.0295. Now, how am I going to find my upper and lower boundaries? What am I going to use? Ooh, be careful. In the previous lessons, we were using X bar because we were finding the confidence intervals for sample means. Here we're finding the confidence intervals for proportions. So instead of X bar, what am I going to use? Your p hat. Good. This formula right here tells you your p hat. So we're going to go equals p hat minus my margin of error and equals p hat plus my margin of error. Now then down here I have an interval. That's to make it a little more mathematical, and sometimes they're going to ask for the interval like this on Hawks. So here's what you're going to do. You're going to type your interval like you would that we learned in Advanced Algebra 2. So parentheses, my lower interval, 0.8429, comma, parentheses, comma, 0.9020. And then close your parentheses. That's your interval. Now, let's write a sentence to interpret our findings. Okay, this sentence is literally just saying, okay, what did they ask us to find? We found these numbers. What the heck do these numbers mean? Okay, we always start with, we are how confident? 90% confident that the true proportion, that's another way of saying population proportion, that the true proportion, and then what are we talking about? Student parking lots. What do they think about the parking lots? Not enough space? Okay, so we are 90% confident that the true proportion of students at this university, because they were specific about that, they didn't say what university, but it's not all students, students at this university think there is not enough parking is between, and then here's the thing, yes, these are proportions, so you can put the decimals, but let's talk about what proportions really are and how our brain understands them a little better. Can we change them to percentages? Like, would that make more sense to us? So instead of 0.8429, what would that be as a percentage? 84.29%, or 0.3, depends on what they ask, and 90.2%. Okay, we are 90% confident that the true proportion of students at this university that think there is not enough parking is between 84.29% and 90.2%. So I'm going to ask you this question. If you were the university president, would this be a problem to you? That's a very high percentage of your student body that thinks there's not enough parking. That's a problem you should probably fix. All right, let's try it again. On number 4, a survey of 47 randomly selected members of a fitness center reported that 61.8% prefer walking or running on a treadmill to any other type of aerobic exercise. I can personally attest that that is garbage. All right. Construct and interpret a 95% confidence interval for the population of fitness center members who prefer walking or running on a treadmill. So, again, this list I created on my own. If you, you know that we had to use 1 minus p hat. If you want to add another slot for that, that's more than okay if that's what you need. So let's figure out these values here. What does x equal? Oh, doesn't x represent how many meet the attribute? Did they tell me that out of that 47 randomly selected members, this many people said they preferred it? No, they in fact gave me a percentage, which means I know my in value, I don't know my x value, and that's okay. That's okay because they already gave me the p hat value. What's my p hat value? 0.618. We only use that x value to find the p hat. So if they give you the p hat, you don't need to find x. Does that make sense? Now we do need n because we need that for our sigma sub p hat, but you don't need x. Now what's my confidence level here? 0.95. Good. What's my alpha? 0.05. What's my alpha over 2? 0.025. Let's find my z value, norm.s.inv of 1 minus that bad boy. Okay. Now, to find your sigma sub p hat, you're just using this formula. P hat times the quantity of 1 minus p hat. So, over n. So, equals square root of p hat times, put it in parentheses, 1 minus p hat, unless you did a cell reference, that's okay, divided by your n value. I didn't put divided by. Then close your parentheses. I'll scroll up here so you can see. Now, how do I find my margin of error again? Z times sigma. And then to find my upper and lower boundaries, we use the p hat. Okay, hold on. C84. What did I do wrong? 0.07. Oh, okay. So lower would be C77 minus C84, and then C77 plus C84. So with our interval is going to be from 0.4791 to 0.7569. That's going to be our interval. And again, we want to write that interpretive sentence. That sentence is going to help us understand what these numbers mean, okay? So, sentence starts with, we are 95% confident that the true proportion of all fitness center members who prefer walking or running on a treadmill to any other type of aerobic exercise is between what? What are my percentages here? 47.91% and 75.69%. So, looking at this information, let's say you owned the gym or the fitness center. Looking at this information, would you think that you needed to have a good amount of treadmills, or could you have a small amount of treadmills? Yeah, you would think that maybe you want to have more treadmills than any other type of aerobic exercise equipment. You can have others there because other people are still going to want to use them, but you would want more treadmills than anything. Okay, so in summary, just like the others, I'm going to give you an in summary. You need to find the point estimate. You need to find the z-value, calculate the margin of error, then calculate your boundaries and write an interpretive sentence of your findings, okay? Now, these formulas are on your purple sheet. You will have them for the test. Now, just like we did for the other guys, we are going to go the opposite direction. Now we're going to say, okay, what if they gave you all this information and said what sample size is necessary to estimate the population proportion within a particular error and a certain level of confidence? Now, this is kind of hard to see. I need you guys to understand that that dude right there is z sub alpha over 2 squared. Okay, it's kind of hard to see because that squared is above that. We're squaring that z value. Okay, then you're going to multiply it by your p hat. You're going to multiply it by your 1 minus p hat. And you're going to divide it by e squared. What do you think that e stands for? Error, the maximum error that you want. That's how you're going to find the sample size, the minimum sample size needed to get you the information that you need. Okay? Now, something that's different when it comes to determining a sample size for population proportion, if an estimate, right here, this is really important, if an estimate of the population proportion is not available, okay, let's say they don't give you an estimate of the population proportion. If it's not available, then the population proportion has to be 0.5. If they don't tell you what the population proportion is, it is 0.5. The reason is because the value of 0.5 maximizes this quantity and thus provides the most conservative estimate of the sample size possible. So if they don't give you the population proportion, they want to give as much leeway as possible, so they're going to use the 0.5 because that's going to give them much leeway, or the most leeway. Hence, if no estimate of the population proportion is available, the sample size necessary to estimate the population proportion to within a particular error with a certain level of confidence is given by this guy. You don't need to worry about that because we're going to get some practice with it. So let's look at number 5. Researchers working in a remote area of Africa feel that 40% of families in the area are without adequate drinking water, either through contamination or unavailability. What sample size will be necessary to estimate the percentage without adequate water to within 5% with 99% confidence? So here's the formula that they gave me. From this z sub alpha over 2, I know I need a confidence level, an alpha, and an alpha over 2 to get my z value. Then I need my p hat value, and then I also put a place here for 1 over p hat, or 1 minus p hat, and then I also need an error. That's where I got this. I got all of this just from this formula. So let's figure out all of this information. What is my confidence level here? 0.99. They said with 99% confidence, so that's 0.9. Which means, what is my alpha? 0.01. And what is my alpha over 2? 0.005. Let's take a second to find my z value, norm.s.inv of 1 minus that guy. That's my z sub alpha over 2. Now my p hat, did they give me a population proportion estimate? Hmm. 40%. Researchers working in a remote area of Africa feel that 40% of families are without adequate drinking water, so that would be 0.4, which means my 1 minus p hat value is 0.6. And then finally, what's my error? Error. Good. It says to within 5%. That means if this is my value right here, they want within 5%. So you can go up 5% or down 5%, which means this is my error, so 0.05. Now to find my in value, you need to follow this guy right here. We're going to take my z value and square it, multiply it by p hat, times 1 minus p hat divided by my error squared. So here's what we're going to do. We're going to type in equals. Click on your z value, and you're going to go ahead and square it. So to the second times p hat times 1 minus p hat divided by error, and again, you're going to say to the second power. Now, order of operations is going to make sure those exponents are taken care of first, so you don't have to worry about parentheses or anything like that. So you should have z value squared times p hat times 1 minus p hat or divided by error squared. And you should get 636.9501. Good? Now, do you guys remember, what are we supposed to do for the sample size always? Round up. So what is the minimum sample size needed here? 637. They're going to need at least 637 people. All right, let's try it again. A school board would like to determine if registered voters in the school district agree with a proposed bond issue for a new elementary school. Find the sample size necessary for the school board to estimate the true population to within 5% with 90% confident. So I'm going to take a second. I'm going to pause. I want you guys to see if you can find all this information on your own, and then we'll come back. So I found the confidence level to be 90%, which means my alpha is 0.1, my alpha over 2 is 0.05, and my z value is 1.64. The p value is where we're struggling. Did they give us two numbers to determine it? Did they say this many out of this many? No. Did they give me a percentage saying that the proportion is this? They did not give me a p hat. And according to the information, if I do not have a p hat, what do I need it to be? 0.5. Which means, what's my 1 minus p hat? 0.5. So what I'm going to do is I'm going to draw a note here, and I'm going to say, we don't know. And since we don't know it, that's why it's 0.5. What's my error? 0.05, yeah. Let's see now if we can calculate. Z squared times p times 1 minus p divided by this guy squared. So again, we're just following this formula, z squared times p hat times 1 minus p hat divided by e squared. And you should get 270.55. So my minimum sample size should be what? 271. Very good. All right, so in conclusion, we have a summary here. Identify your p hat or your p-value and your error. Find the z-value. Calculate your n value, and then round up. The formulas are also on your formula sheet. Okay, that's what we got.